Welcome to Just Mathematics. In this edition, we will continue with solving the problems in the 2025 competition. In the last video, we were able to solve question 1, part 1. These are the 3 compulsory questions in part 1. We solved number 1A and number 1B in the last video. Today, we are going to go to number 2. The question in number 2 goes thus. The first tenth and last terms of an arithmetic progression are 9, 40.5, and 42 and 425.5. respectively. Find A, the number of the terms. B, the sum of all the terms. And C, the 70th term. Okay, that's the question for number 2, part 1. It's an arithmetic progression APGP question, but this particular one is an arithmetic progression. Let's move on to solve it. Have you looked at the questions very well? Look at the question very well. So I haven't looked at it. Let's go on to solve the question. So we move to solution. We have to get our parameters right. In the question, we're given some parameters. But before anything, in answering questions in an exam, for maximum scores, because points will be given to steps taken in solving a problem. The first thing to do in this type of question is to write the formula. Write out the formula. The formula is Tn, the nth term, equals A. A is the first term, plus into bracket n minus 1 d. Let me explain these terms. A is the first term of a progression. Take for instance, if you have a progression as 2, 4, 6, the first term is A and it is 2, since it's the first of the figures in that progression. N is the number of the position. Take for instance, let me write it out. E.g., you have 2, 4, 6, and so on in a progression. A, which is the first term, here we say n equals 1. So n, when n is 1, then the figure there is 2. So n is the position. When n is 2, who can tell me what the figure there is? When n is 2, the figure there will be what? 4. Good. N, when n is 3, the figure there will be what? Someone tell me. 6. Good. So n is the position, of the progression. That is what n is. D is the difference. D is the difference. Because in arithmetic progression, it either increases or it can decrease. So normally to get the difference, you subtract. There are cases you subtract to get the difference. So to get the difference, you have 4, what is in the t, when t is 2, Tn, e.g. T2, that is T2 is the number or the figure in the second position. Here our T2 is 4. So to get the difference, you have T2 minus T1 or T3 minus T2. They will always give you the same thing. 4 minus 2 gives you 2. 6 minus 4 gives you 2 still. So the difference is a common one in a particular progression. Therefore, in this particular example, our D is 4. So explaining the terms of this equation. So we already know our Tn. Tn is the number in the particular position you are looking at. Take for instance, in this example I gave, T3. Who can tell me what T3 is? T3 in that example is 6. A is 2. N is the position you are looking for. Can be the first, can be the second, third, and D is the difference. So write out the formula for this. In the competition, just writing out that formula attracted 1 point. in that solution. So don't forget, you are right. In the question, we have our A. Who can tell me what our A is? Go back to the question. It says the first, 10th, and last terms of an arithmetic progression are 9, 40, and 425.5, 40.5, sorry, and 425.5 respectively. So who can tell me what, from that, the information given in that question, who can tell me what our A is? Did you say 9? You are correct. 9. Our A is 9. Our T10, tell me what T10, that's the number in the 10th position which we were given, is 40.5. Good. But the last information we were given there is, they said in the last term, and we don't know what that last term is. We don't know what position it is. So we only know that they said the number in the last term is 425.5. So write it as Tn. We don't know what the Tn. We don't know what the last term. We know what the last term is, but we don't know the position. We don't know whether the series is 10 in number or 20 in number. We'll find out later. So having written that, then you start to solve. We want to know we want to get some parameters in the given parameters we have. So we know that the 10th position, we know T10 to be equals to, follow that formula, plus n minus 1 d. We can get what our d is. So we know our T10 to be equals to, we know our A to be 9, plus, we are dealing with the 10th position. We know what is T10. Our T10 is 40.5, right? So we know the position, 10 is the position, minus 1. But we don't know the difference. But we know that it is equals to 40.5. 40.5. Remember, we're given Tn to be 40.5. The 10th position, sorry, to be 40.5. So you know that. Solve that equation. We have 9 plus 10 minus 1 is 9 times d plus 9d is equal to 40.5. Do your mathematics. You have 9d to be equal to 40.5 minus 9. When this is plus 9, when it crosses the equality sign, it turns to minus. So we have our 9d to be equal to, who can deduct that for me? Do that for me and give me the answer. Good. We have 31.5. 31.5. Therefore, our d will be, divide this place by 9. Whatever you do it to this side too. Divide by 9. So therefore, our d is 3.5. So that is the first one. Got your d to be equals to 3.5. That step attracted 2 marks. That step attracted 2 marks. All right, let's go on. Having gotten our d to be 3.5. Then we can go on. Since we know the last term, we can go on to get the position of that ninth term. We can go on to get the position of that ninth term. We know the figure that is there. And we know that our last our Tn, let's go on. So we don't know what Tn is, but we know that the last term is 425. We want to know what that is. So put in your figures. The first one is 9 plus, we don't know the n. We don't want to know the nth term that gave us 425.5. No, our difference to now be 3.5. And we know that that last term is 425.5. Okay. Open the bracket. We have 9 plus 3.5n minus 3.5. This 3.5 must multiply each term in that bracket. 3.5 times n gives us 3.5n. 3.5 times minus 1 gives us minus 3.5, equal to 425.5. We want to know what our n is. That is the last position of that progression. Therefore, gather your like terms. 9 minus 3.5. 9 minus 3.5. I see that I'm doing it myself, so I expect you to do it too as this class is going on. So we have 3.5n plus. Why is it plus? This is plus 9 minus 3.5 plus 9 minus 3.5. That will give us plus 5.5 equal to 425.5. Gather like terms further. This moves there. Then we have 3.5n to be equal to 425.5 minus 5.5. Therefore, your 3.5n equal to, do it as I'm doing to myself. Do yours and give me the answer. Write the answer in your notes as you're following me. That is 420. So we have 420. Therefore, to get your n, you divide both sides by, and tell me what you're going to divide both sides by. To remove, divide it by 3.5, divide this place by 3.5, so that we can get our n. So 3.5 here cancels 3.5 here, leaving you with n equal to 420 divided by 3.5. That is 120. Good. Excellent. The nth position, the position that gave us 420, the position that gave us 425.5 is the 120th position. You can do it. If we have time, you can do it at home. You can start with 9 and continue to add 3.5. If you add 3.5 to 9, your first term is 9. Your second term will be what? The second term will be 12.5. Add 3.5 to 12.5. Your third term will be what? 16. Continue to add like that. You can see that this is your second term. This is your third term. Continue to add like that till you get to the 10th term. You find out that the 10th term is what they gave you up there. Find out that the 10th term is what they gave you up there, which is, what is our 10th term? 40.5. And if you continue to do it to the 120th term, you'll find out that the figure in the 120th term will be 425.5. So arithmetic progression helps you because it is stressful. You can find out that if you want to continue to add 3.5, which is the common difference, continually to the 120th position, is a lot of work. So arithmetic progression saves you that work gives you. So the 120th term is 425. So that is the solution to that. So by getting 120, you got yourself another point, 2 points. Let's go to the last question. The last question in this particular question says, we have solved the first question, the number of the terms. The number of the terms, we have solved it. We couldn't have gotten the number of the terms without getting the common difference. So we got the common difference first. So we got the number of the terms. All the number of the terms there in that progression is 120. So the second question says the sum of all the terms. Then the third question says the 70th term. Let's get the sum of all the terms. We already know now that we have 120 terms. So in answering questions, what did I say you do first? You write your equation that shows that you know what you are doing. So we know Sn, the summation of arithmetic progression, Sn is n all over 2 into a big bracket 2a plus into a small bracket n minus 1 d, close your big bracket. That is how to get your summation. You want to add up all the numbers starting from 9 to 12.5 to 16. Like that, you want to add it up to the 120th term. This is the formula that will give you the addition of all those numbers. So we have our position that we want to add up. We want to add up all. So the position, the position which is n is 120. A lot of students made mistakes there. A lot of students made mistakes. What they told you to add up is the total progression. So you are going to add up all the numbers in the whole 120 positions. So 120 divided by 2 into, your first term, 2 times 9, plus, the term you are going to 120, isn't it? Minus 1. And your common difference, which is 3.5. If you're able to get it to here, in fact, you've already finished solving the question. So let's start. 120 divided by 2 will give us 60. Into 2 times 9 is 18. Plus 120 minus 1 is 119 times 3.5. Get your 119 times 3.5. You can quickly do it. 119 times 3.5. I'm doing mine here because I want this to be as practical as possible. 119 times 3.5 is giving us 416.5. So we have 60 into 18 plus 416.5. Add it up with 18. plus 18. You have 60 into 434.5. This is 0.5. Multiply that by 60. Your answer will be 26,070. That will be your answer. So the sum from the first to the 120th position is 26,070. You can add it. In fact, mathematics is very, very interesting. So you can start to add it up from 9 to 12.5 to 16. Continue like that till you get to the 120th position. You find out that the addition of all those numbers will give you 26,070. Good. Got that step? That attracted 2 marks. Then the final question, that's the question C. It says, find the 70th term. We are told to find Tn equals to T70. We are told to find T70. So therefore, using the equation above, you know your n to be 9. Your a to be 9 plus you have your n. We are looking for the 70th term minus 1, and you know your d to be 3.5. So here we are, 9 plus 69 times 3.5. And tell me what 69 times 3.5 is. Work it, I'm doing mine here. 69 times 3.5. That will give you 9 plus 241.5. Add this up. You have your answer to be 250.5. So your T70 is 250.5. Very simple. If you got that, you have 2 marks. How did we grade this competition? Exactly how I've said it. So take for example, if you did not write your formulae, you know in this question now we're able to gather 2 formulae. If you did not state out the 2 formulae as at when needed, already you lost 2 marks. So compared to somebody that stated out the information, you can say that you're already two marks down if you did not put your formulae down. So in such competitions like this, you have to be meticulous about your steps. Thank you. That is answering number 2. In this same video, I will quickly answer number 3 before I go on a break. I will quickly answer number 3. Let's start number 3. The question in number 3 is solve two raised to power x all raised to power 2 minus 3 into 2 raised to power x plus 2 equal to 0. That is the third question in part 1. The 3 questions in part 1 were compulsory. they were compulsory. So you must have answered them to be able to get the maximum marks you got. Therefore, for questions like this, the very first step is this is a quadratic equation. But quadratic equations like this, we expect you to go further because you can't solve it like this. So the very first step, which attracted 2 points, was to state that let 2 raised to power x equal to anything. You could say let it equal to p, you could say let it equal to a, you could say let it equal to anything. In this instance, I'm going to say let it be equal to p. Writing out this statement attracted 2 marks. Therefore, going back into the equation, wherever you see 2 raised to power x, put in p. So we have 2 raised to power x here squared. So we have p squared minus, you have 3 times 2 raised to power x, 3p plus 2 equal to 0. Anybody that is in the top class in the secondary school will definitely be able to solve this. What you need to do here now is to factorize. And there are many, I think we have about 3 or 4 methods of factorization, including your almighty formula. So we'll factorize, but I'm just going to go through the worked process here. Factorize. After factorizing, you get your p minus 1, p minus 2. If you multiply, if you want to expand this now, p, you want to expand it, let's expand it here to see that we are going to get back this. Don't forget your equals to 0. Expand this, we have p times p to be p squared. We have p times minus 2 to be minus 2p. We have p minus 1 times p to be minus 1p or p. We don't normally write 1p, we write p. Then we have minus 1 times minus 2. When minus and minus multiply, it turns to plus 2 equals to 0. Let's add it up. Gather like terms. Minus 3p plus 2. You can see that got back our equation. So that means factorizing this way is correct. So therefore, we have p minus 1 equals to 0 or p minus 2 equals to 0. Here, we have p equals to 1 or p equals to 2. Okay, that is not the end. Remember that you said let 2 raised to power x equals to p. So therefore, you are saying your 2 raised to power x is equal to 1 or your 2 raised to power x is equals to 2. In this scenario, in this first scenario, we can say that 2 raised to power x is equal to 2 raised to power 0. Bring both of them to the same base so that you can equate the powers. This is 1. Anything raised to power 0 is 1. Go back to the law of indices that we treated in some of our videos, earlier videos. Anything raised to power 0 is 1. So, and we have 1 here. We need to bring it down to the same base. So we say 2 raised to power 0. Therefore, giving our x in this scenario to be equals to 0. Come back to this scenario. You have 2 raised to power x equals to 2 raised to power 1, because this 2 is the same thing as 2 raised to power 1. 2 raised to power 1 the same thing as, but because you have brought it to the same base, therefore our x here equal to 1. The solution to the equation, therefore, is x equals 1 or 0. That is your answer. Let 2x equals to p that you wrote attracted 2 marks. Putting p into the equation attracted 2 marks. Writing out p minus 1 into bracket and attracted